Today we're diving into a really exciting new model from Microsoft Research called BEIT-3. And let me tell you, this is a massive step towards a goal that a lot of people in AI thought was still years away. Building a single, unified model that can understand the world through both text and images, kind of like we do. So let's get into what makes this thing so special. To really wrap your head around why this model is so revolutionary, let's just start with a simple question. What if an AI could learn an entirely new language, but instead of being made of words, this language was made of pictures? Just keep that idea in your back pocket because it's pretty much the key to unlocking this whole thing. All right, first up, let's get some context. To really get BEIT-3, you have to understand this huge trend that's happening in AI right now, something researchers are calling the big convergence. For years, the dream, the holy grail for a lot of AI labs, has been to stop building all these separate, specialized models. One for text, another one for images. The real goal is to create a single, general-purpose foundation model that can handle all these different types of data, or modalities, all at the same time. And BEIT-3, well, it's a giant leap towards making that dream a reality. So the big question is, how on earth did they pull it off? This gets us to the core idea behind BEIT-3. And what's so brilliant about it is that the answer isn't more complexity, it's actually simplification. This quote from the paper really says it all. The researchers just decided to treat images as a foreign language, and they even cleverly named it English. So instead of building some brand new, complicated system, they just taught the AI to be a translator between regular old English and this new visual language. And how did they teach it? With a super simple but incredibly powerful game called masked data modeling. All it is really is fill in the blank. You show the AI some data, text or an image, with a piece missing, and its only job is to guess what that missing part is. That one simple task is all BEIT-3 needs to learn. And this shows you exactly how that works for both text and images. With text, you might give it a sentence like, a baseball, throwing a ball, and it learns to predict the word player. Well, for an image, you do the exact same thing. You show it a picture with a chunk blacked out, and it learns to fill in that missing patch. See? It's the same game, just a different language. So here's the key insight. An image gets broken down into a sequence of patches, just like a sentence gets broken down into a sequence of words. To the AI, this picture of a baseball player isn't one giant object, it's a sentence made up of visual words that it can actually read and understand. So how does it learn to do the translation? By looking at millions and millions of image-text pairs, basically pictures that have captions. These pairs act like a Rosetta Stone for the AI. By seeing the English sentence, which is the image patches, right next to the English sentence, the caption, the model starts to figure out the connections and becomes fluent in both. Okay, so let's take a peek under the hood at the architecture that makes all of this possible. You'll see how this single model is designed to wear a whole bunch of different hats. The engine powering BEIT-3 is something called a multi-way transformer. The best way to think about it is like a brain. It's got this shared core that understands the deep connections between images and text, but it also has these specialized experts that are masters of either vision or language. This really clever modular design is what makes it so powerful and efficient. And because of that design, this single BEIT-3 model can switch jobs on the fly. It can act as a vision-only expert for stuff like identifying objects, or a language-only expert for understanding text, or it can become a fusion expert that combines both skills to answer really complex questions about an image. It's one model, flexibly doing many different things. And it does all of this at a pretty incredible scale. We are talking about a model with a staggering 1.9 billion parameters. But what's really a huge deal here is that it was all trained on publicly available data. That means other researchers can take this work and build right on top of it. Okay, so this unified approach, it sounds really elegant in theory, right? But does it actually work in the real world? Well, the results, this is where the story gets really, really exciting. The short answer is, oh yeah, it works. BEIT-3 didn't just perform well, it set new state-of-the-art records across a huge range of both vision and vision language benchmarks. It basically came in and topped the leaderboards. Let's just look at one example. Visual reasoning. This is a crazy hard task where the AI has to judge if a sentence accurately describes a couple of images. The previous best model, Coca, maxed out at 87% accuracy. BEIT3 didn't just beat that record, it completely smashed it, hitting 92.6%. I mean, a jump of over 5.5 points on a tough benchmark like this is practically unheard of. It's a massive leap. And that wasn't a one-off. As you can see here, it's pretty much the same story across the board. For core vision tasks, it set new records in object detection, in semantic segmentation, and even in classic image classification. It's consistently the best or right there at the top, no matter what you throw at it. So what does this all mean for the future of AI? What are the big takeaways from all this? Well, here are the key things to remember. First, BEIT3 proves that sometimes the simplest idea is the most powerful one, using just one fill-in-the-blank game to get these incredible results. Second, it's more efficient, which makes it more practical to actually train and use. Third, it's a huge step toward that big dream of a single general-purpose AI. And finally, by using only public data, it's opened the door for researchers everywhere to build on this amazing breakthrough. And that brings us to a final thought. The whole idea here was to treat images as a language, to be learned and translated. So as AI becomes truly fluent in English, you just have to wonder, what new things will it see in our world that we've missed? And what incredible new stories will it be able to tell us?